I'm glad you're here for part 2. Now we're going to multiply and divide rational expressions, okay, which is very reminiscent of multiplying fractions. So if we have to reduce these fractions to simplest forms, there are a couple of ways you could do it, but probably the easiest is to think of 12 not as 12, but as 3 times 4. Okay, factoring it completely, if you get my drift. Now we can cancel out the 3 and multiply across. So we get 20 on top and 7, because that was a 1, in the denominator. So 20 over 7. This is exactly what we're going to do. Okay, we are going to factor the numerators and denominators, multiply the numerators, and multiply the denominators. And then simplify, if we can, or write it in lowest terms by applying the fundamental principle, canceling anything that we've got left. Let's dive into an example. Multiply the following rational expressions. The first thing we are going to do is factor. So the numerator on the left isn't going to change. Neither is the denominator. On the second fraction, though, we will have an m over, and m factors out there. M times m minus n. Now, I guess one thing I could do is I could write this as m minus n, m minus n, because it is squared. That's what that means. Now, if we try to cancel some things, we have an m minus n, m minus n. Okay, that leaves us with m minus n, and we have an m in the numerator as well. And we have an m plus n. Now, I probably should have noticed this earlier, but the m's cancel out there, which leaves me with m minus n over m plus n. Factor everything completely, cancel out any common factors, multiply together, and then simplify if there's anything left to do, which there was in our case. And of course, pause, go back as you need to as you're writing these things down. Okay. Next expression we have got quite a few things to factor. The numerator in the upper left is a difference of squares. So that is x plus 1, x minus 1. The denominator in that same fraction, well, a equals 1 here. We have just an x squared, so we can try to factor that one. And that is going to be, let's see, an x and an x term. We need two numbers that multiply by negative 4. So 4 and 1. And since we need a negative 3, we'll have a negative 4, positive 1. Okay, we have an x squared over here. And, oh, there's a GCF in the denominator there. So we factor out an x, and we're left with x squared minus 1. Oh, we're not done, because that factors. Okay, I'm going to write this kind of messy here. That is x, x plus 1, x minus 1. Oh, I made a mistake. Go back. There should not be a squared there. Huh. Okay, so if we factor an x out, we get an x minus 1, not an x squared minus 1. Okay. Good, that'll work out better. Okay, now we want to find things that cancel out, common factors. Get my red pen. And it appears that we are going to have an x plus 1 that cancels. We also have an x minus 1. And actually we have an x. So we have an x squared over x. So x will cancel out, and we are left with an x in the numerator and an x minus 4 in the denominator. Now you try. So pause the video, attempt it, see how far you can get, and then play it again and see what I got and see if they match, and if they don't, fix it. Okay. Now I know that the upper left factors, 2x plus 1, x minus 1, and I know that the upper right factors into an x, we have an x, we have a 2 and a 1, a minus 1 and a positive 2. Pretty confident that the bottom right's going to factor into a 2x and an x. Let's see what numbers I can come up with. 6 and 1 is too much. 4 and 3 is too much. No, 2 and 3 is what it would be. 3 and 2. I'm really checking the inner product there. So I've got 2x squared, 3x, and 4x gives us 7, and then 3 times 2 gives us 6. Okay, now I know that x cubed minus 1 factors. Okay, so that is going to be an x minus 1, that is a difference of cubes,